Hi everyone, and welcome to CariBot, which is our final project in making an iiwa draw caricatures in simulation using Drake and MeshCat. So we decided to choose caricature drawing as our task because it presents a really interesting manipulation problem. So as you can see in this video demonstrated here, caricatures inherently have a technical and creative component in that you really want to emphasize certain features of the image or caricature you're trying to present. At the same time, you can't lose recognizability without sacrificing, the comical nature of the caricature itself. So for our project, we really focused on the technical precision required to generate and then draw a caricature of a given input image. And so in the future, this could have use cases including facial imaging drawing, where drawing features are important, like police suspect drawings or courtroom sketches, or even drawing AI-generated faces. And the precision itself could be useful in non-facial drawings like architecture or manufacturing. Now to move on to our approach. So CariBot consists of two subsystems. So given an input image, we feed it into our image processing system, and then that generates a set of trajectory points that the manipulation system then uses to draw the actual output image. Now the first step in our image processing subsystem is to create a caricature from a given input image.
And to do this, we referred to the CariBot paper by Gu et al. And recreated their machine learning model in Google Colab. Using this model, we generated caricatures of different input images, and as you can see, there's like a variety of different warping techniques that are applied pretty randomly to generate like a diverse set of possible caricatures. Here are some other results that we have, and basically our model our pipeline displays 5 randomly generated caricatures and allows the user to select one that they want to draw, such as this one. The second step was to process the caricaturized image using the canny edge detection algorithm, which through testing we determined was the best way to pick out a set of definitive contours that our robot should draw from an image. So the steps of this algorithm, just very quickly, were first to convert a picture to grayscale. Secondly, to apply Gaussian blurring to reduce noise in the image. Third, using an intensity gradient, definitive high contrast edges were identified. And then finally, using some kind of thresholding process, more edges were more clearly defined. And basically, here are some results of the canny edge detection algorithm. As you can see, the new image has a bunch of lines that are somewhat unnecessary to fully recreating the image. So to deal with this, we also filtered some of these contours by arc length to remove small ones that were not necessary and end up with a better picture of the subject. And this was the original input photo that we ran the algorithm on.
Now, moving on to the manipulation system. We'll also add in a video of CariBot drawing a caricature on the side here, since the process takes quite a bit of time. For CariBot's manipulation system, we took Russ's drawing example, combined it with the robot painter class from a previous pset, and changed the controller to diff-ik. We welded the chalk to the robot's right finger, and when the chalk comes into contact with the chalkboard, a line is drawn following the robot's trajectory. We chose to base it off of the robot painter code since the pset featured the iiwa following given points, which encapsulates one of the main features of CariBot. To generate the actual trajectory, we take the points from edge detection and then apply scaling, offsets, and rotations in order to translate the image into the world frame. We also had to insert additional lift points at the start and end of the line in order for the iiwa to transition between distinct lines without drawing on the chalkboard. Here, we can see the output image of the iiwa drawing a caricature of the rock. We also faced many challenges in both subsystems during the project. For the image processing subsystem, we had trouble filtering out the lines that we did not want, since it varied quite a bit between images and often produced very questionable results. Then, during the manipulation, we had a lot of trouble controlling how the robot arm lifted up from the chalkboard, which caused a lot of extraneous lines. And now that CariBot is done drawing, let's take a look at the results. Here we have Russ in his many stages, and here's the final result. In the future, there are many areas of improvement for CariBot to work on. Here are some of them, such as noise reduction and more cartoon-like caricatures, as well as different applications for CariBot, such as using different art utensils and doing non-facial drawing tasks. Thank you for your time.